So this is Unit 7, Lesson 2, two-dimensional arrays. Most of you, when you think of a two-dimensional storage space, think of a table where you have rows and columns. That is not the correct visualization for two-dimensional arrays. In fact, it's incorrect for anything more than two-dimensional arrays. It won't work. Because if you get the three-dimensional arrays, maybe you could do a cube. But once you get the 4, 5, 6, 7, 8, 30-dimensional arrays, there's no physical structure to do that. So it doesn't make sense to start with an analogy that falls apart almost immediately. We can use two-dimensional arrays to represent tables of data. So that's where the confusion comes in. A lot of times when we're first starting, we do use two-dimensional arrays to represent tables, but that's not really the major power of them. It's in the ability to represent multiple dimensions, 3, 4, 5, 6. Like, for example, suppose you wanted to keep track of x, y, z, and time. Something called space-time. That's 4 dimensions. You could not do that in any construct that you currently know, right, to keep track of all that information. You don't have something to do that. So two-dimensional arrays will allow us to do that. First off, quick review of one-dimensional arrays. They store just one piece of information, one type of data. They're indexed from 0 to length -1. And they're used to store large amounts of data because array lists become cumbersome when you're talking about huge amounts of data. They're too memory intensive, so arrays have their purpose. For a two-dimensional array, all you really need to think about is that it is an array of arrays. So visually what that looks like is this. Let's say we have an array of length 3. So indexed 0, 1, 2. Then inside each of those 3 blocks, we have another array stored. Now the length of each of those arrays can vary. And in fact, for our first example, I'm going to vary them so you truly understand what's actually getting stored there. So in the first box, let's say we put a 3-dimensional array. In the next box, maybe we'll put a 4-dimensional array. And in the last box, maybe we'll put a 2-dimensional array. Inside of each box is stored the same thing. It's an array. In fact, it's probably specifically an array of ints, or an array of doubles, or an array of strings, because arrays can store objects. An array of students, array of books, each of them different sizes. But for, I'd say, 99% of all of our cases, having these be different sizes isn't really effective for most information gathering. Normally, the number of values in each dimension are the same. In other words, it's a square. It's a 3 by 3, or it's a 3 by 10, where each row is 10, or a 3 by 15, where each row is 15. You wouldn't do a 3 by 7, and then an 8, and then a 9. It wouldn't make any sense in terms of most of the data that you experience. But Java doesn't care. It doesn't matter to Java how we're setting this up. Java's fine with however you want to set it up. So you could do this. In each box, put a different size array. However, what makes more sense is to do this. Here we have an array of arrays, and each of these arrays is the same length. So this is indexed 0, 1, 2. This is indexed 0, 1, 2, 3. This is 0, 1, 2, 3. This is 0, 1, 2, 3. So the length of this outside array is 3. Because we're designing this stylistically so that each element of the first array stores an array of the same size, we can say the length of the second array is 4. So if we wanted to store information that was in a table, that's row major. We'll talk about that in a second. Row major means the rows come first, 3, 4. We would say that this is row 0, row 1, row 2. This is column 0, column 1, column 2, column 3. So this is the typical storage setup, our tables, that we're used to. But if we want to go 3 dimensions, that doesn't work anymore. We have to do like a cube, right? And kind of go out with this in 3 dimensions, like this, right? Something similar, or something like that. Maybe that goes the wrong direction. I mean, it'd be a really weird construct to draw. That'd be awful to try to figure out. But in here, it's not. Suppose in each one of these I put another array. Let's just make it simple, a 2-dimensional array. So this is indexed 0, 1, 0, 1, 0, 1, 0, 1, and so forth, all the way through. So if I wanted to get to any particular square, let's say I wanted to get to this square right here. The coordinates, so to speak, of that square would be the first row of the first array. And inside there, inside the array that's stored there, I want to look at the first row. And then inside there, I want to look at row 0. Or element 0. So it's element 1, element 1, element 0. So if I want to identify its location, I would say it's 1, 1, 0. It's coordinates, so to speak. Hopefully you can see that it's fairly easy to carry this out infinitely. We can go as many dimensions deep as we need to. We want to do that space-time dimension and include time, x, y, z, and time. We could very easily put in another array inside of each of these boxes. So inside of this green box, we could put another array. Or if you want it to be really interesting, you could put in an array list in there. It doesn't have to be an array. So Java gives us this ability to get very flexible in the way we store information, much different than what we kind of are stuck with in Excel. This gives us a lot more power than we could possibly imagine that we would have in Excel or some other type of table. In order to create a two-dimensional array, you have to declare an array of arrays. And furthermore, we want to declare this. You have to read this declaration statement really carefully. Inside this array called grid, we're going to put an array of ints. So the integer is referring to what's in the lowest level. Right? That's the values that are actually going to get stored in the box. This first thing right here tells us it's an array. So the big array comes first. It's a grid array. And inside that, we're going to store arrays. And those arrays are going to be integers. So we have a new array of integers inside an array. The first array is dimensioned 4. So it has 4 rows, because this is what's called row major. The row comes first. As far as Java is concerned, there's no such thing as rows and columns. Java just has arrays that are inside arrays. It doesn't care if you call it a row or a column. You could turn the computer on its side, and it's not like the information's going to change. Row and column is just your physical, real-world representation of a table on a piece of paper. But in order to be consistent for the AP exam, or consistent in real world, programmers have to relate these things to real things. Code has to match something real. Otherwise, why would we do it? So we give a word that says it's row major. So we know that we're doing row major. If I was going to do column major, I would not change the code. Nothing would change. As far as Java is concerned, it's the same thing. Java would say, oh, column major. That doesn't mean anything to me. We're still doing 4, 3. You would just then say the first number represents the columns, and the second number represents the rows. So if we were doing row major, it looks like this. 0, 1, 2, 3. 0, 1, 2. That's row major. Comes first. If we're doing column major, I kind of squeezed this in really tight. 1, 2, 3. 0, 1, 2, 3. 0, 1, 2. Column major. Here. Row major. Here. Java doesn't care at all. You can decide how you want to do it. But when you're dealing with it in the real world, you have to make a decision about it, and stylistically, you have to write it in a comment somewhere. This is row major. So you know. Both of these, whether it's row major or column major, the way Java sets it up, because of the order, is like this. 0, 1, 2, 3, and inside this one we have 0, 1, 2. And inside this one we have 0, 1, 2. And inside this one we have 0, 1, 2. And inside this one we have 0, 1, 2. Whether you call it row major or column major, because the 4 comes first, Java's going to set it up like that every single time. Row major means that the rows come first. So 8, 4 means there's 8 rows and 4 columns. That's row major. Column major would be the other way. The one you really need to pay attention to is row major, because the AP exam is going to do everything in row major. Everything is done in row major exam. Okay, so this is how we use a for loop to traverse a row major array. So I'm going to talk through this, And then if you have questions, you're going to have to either email me or in class you can ask them. So let's talk through this. So in our array of arrays, visually, it looks like this. 0, 1, 2. And we'll make it simple for our purposes. 0, 1. So the rows are indexed 0, 1, 2. The columns are indexed 0, 1. When I talk about the length of grid, I'm asking how many elements are in that array. So the way Java is storing this is an array of arrays. So the length of the first outside array, which we're calling the rows, is just the name of the array dot length. This is where it gets tricky. The columns, the length of the columns. Well, since we made the agreement to make every array within our arrays the same size, all we really have to do is address one of the rows and say, what's the length of the array in row 0? Now, I could have just as easily have said row 1 or said row 2. Because we stylistically decided to make every array inside of our array to be the same size, it doesn't matter which one I get the length from. The length of the array in row 1, or row 0, is the same as the length of the array in row 1 because we decided to make it that way. There's nothing in Java that says that has to be true. We could have had to deal with different size arrays, but that would mean we wouldn't be able to do a for loop in here. We'd have to have a for loop, 3 separate for loops for each row. That would be a pain. So in order to make this functional, we make the decision as programmers, stylistically, to say, every array is going to be the same length. Now, we could decide that this goes to a 3, and then the last value has 26, has an array of 26 in it. We could decide that. Absolutely, we could decide that and put that in there. But that would mean our for loop would have to stop early, right? Instead of this being grid.length, it'd be grid.length minus 1 because we know there's a special case at the end to deal with that. Why would you might want to do that? I don't know. But Java designers said, let's give them the flexibility to do it. Let's take the reins off. Let's not make them fit into one specific thing. So this structure that we've talked about works for 99% of all cases. So you could either memorize that to get to the second dimension, it's the name of the array, bracket 0, bracket dot length. Or realize all you're doing is getting the length of the array that is in the first row of the array grid. And if you read it that way, this code makes a lot of sense. That's exactly what it says. This is the length of the outside array, grid.length. This is the length of the array stored in the first element of that array. That makes a lot of sense. It's an array of arrays. So you have a choice. Either think of it that way, as an array of arrays, and then this code is not too bad, Or if you prefer the table model because that's easier for you to think about in terms of the real world, then you have to memorize this bit of code. To get to the number of columns, it has to be the name of the array, bracket 0, bracket dot length. So it's either memorize code or understand it. I always prefer understanding code, but you can decide where you're at. In order to address a particular row and column, if I want row 1, column 1, well, really I have to say I want row 1 of the first outside array. And then, of the array that's stored there, I want element 1. So I want the first element indexed of the outside array, index 1. And then I want the first element, index 1, of the array stored in that array. So when we do 1, 1, that's going to give me that element right there. So here is an example where we have some test scores. And we're going to fill an array. It actually takes a parameter of a two-dimensional array. We're going to traverse through the outside of the array and then traverse through the inside of the array and put a random number in each block. So that randomly populates the array. Then over here, we're going to do the same thing we did in the last page and print every value in the array. Again, we need this two set of loops, one inside, one outside. The first one progresses through the outside array. The second one progresses through the inside array. If you had another dimension, you would need another loop. Three-dimensional loops are not on the AP exam, just two-dimensional. So if this is, if two-dimensional is hitting your limits, that's okay. But if you can kind of expand your thinking a little bit more, we can go as many levels as we want. There's no limit to this. The only thing that limits it is the memory of the computer. Finally, we're just going to call our methods and print some stuff out. So we print test scores. Test scores is a new array. That's 25 rows, 4 columns. If you think about it, that might be 25 tests for 4 students, or 25 students, 4 tests. However you want to think about it. You got to decide, again, what's the rows represent? What does the columns represent? Basic science. You choose what the axes represent. It's up to you. In math, most of the time, we just tell you what it represents. In science, you have to decide. You have to make a decision. In computer science, you have to decide, what does it represent? So we'll print the test scores, and then we'll randomize those test scores and then print them again. So the first time, it should be a bunch of nulls. So that's it for two-dimensional arrays. There is an exit ticket and also a practice assignment. You really need a practice assignment for this to really kind of understand it. But this is really the basic structure. How to access individual items in the array, how to set it up, how to write a method, how to print them out, how to use that. So this is a very important piece of code right here for your information. So that's it. Never stop coding. 1, 2.